Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on linear time invariant discrete time systems, that is nothing but convolutions. See empathy, how convolution in real life. First we can give the input signal, the initial signal enters the system, and then system blocks diagram, a visual representation of the system component is created. Impulse response, the system response to the brief input is determined, and then output signal, the process signal emerges from the system. It is used in audio ecosystems, image blurring and sharpening, filter noise in digital communication, heart rate signal smoothing. See, what are all the mind map nodes in convolution is nothing but input x of n, output y of n, and impulse response h of n. Next one, define convolution sum. The convolution sum relates the input, output, and unit sample response of the DT systems. Linear convolution is a very powerful technique used for analysis of linear time invariant discrete time systems. Output y of n is equal to x of n into h of n. That is nothing but input signal into impulse response signal. Next one, these are the methods of convolution sum. Four methods available to compute convolution sum, that is nothing but definition method, graphical method, tabulation method, and multiplication method. Definition method is direct application of the convolution formula, and then graphical method is visual representation of the convolution process. Tabulation method, organized table based approach for computing convolution sum. Multiplication method, utilize multiplication in the frequency domain. Next one, these are the steps to find convolution sum. Four steps involved in computing convolution sum, nothing but folding, shifting, multiplication, and summation. How to find the convolution sum? Let capital M be the total number of samples of x of n and capital N be the total number of samples of h of n. Then the total number of samples in y of n will be m plus n minus 1. This is the condition to find the convolution sum of the discrete time system sequence. Next one, this is the ideate part, representation of the convolution sum. First, input sequence can be already given as graphical representation, and input sequence 1 we can find out the convolution sequence by using either definition method, multiplication method, tabulation method, or graphical method, right? This is the representation of the convolution sum. Next one, first input sequence can be given as x of n, and also impulse response sequence can be given as h of n. The circular convolution sequence can be represented in terms of yc of n, and a linear convolution sequence can be given as y of n. For the input sequence into impulse response sequence, by using either multiplication or tabulation method, we can get the convolution sum of the sequence. That is nothing but 0 for y of 0 is equal to 1, y of 1 is equal to 2, right? Y of 2 is equal to 4, y of 3 is equal to 6, y of 4 is equal to 6, y of 5 is equal to 7, y of 6 is equal to 5, y of 7 is equal to 4, y of 8 is equal to 2. This is the output sequence of the convolution sum. Input sequence into impulse response sequence. Next one, these are the properties of convolution sum. It can be classified into commutative property, associative property, and distributive property. Commutative property can be defined as y of n is equal to x of n into h of n, or h of n into x of n. When the input sequence x of n can be given to h of n, which can produce output as y of n. H of n, which can apply to the input sequence x of n, which can produce the output as y of n. Next one, associative property, x of n multiplied with h1 of n again multiplied with h2 of n is equal to x of n into h1 of n into h2 of n. X of n multiplied with h1 of n again multiplied with h2 of n, which can produce the output as y of n. Right hand side sequence, x of n can be multiplied with h1 of n into h2 of n, which can produce output as y of n. Distributive property, x of n into h1 of n plus x of n into h2 of n is equal to x of n into h1 of n plus h2 of n. X of n multiplied with h1 of n and h2 of n, going to add these two signals, we can produce the output as y of n. Right hand side is sequence x of n multiplied with h1 of n plus h2 of n, which can produce the output as y of n. Next one, input output transference. When x of n is applied to h of n, which can produce as output as y of n. For linear change, or x dash of n can be applied to h of n, which can produce the output as y dash of n. Next one, prototype, how it can be applied with real-time simulation. First we can go into graph of x of n and flipped has a h of minus k. Summation points of each n. By using MATLAB or Python demo, we can going to analyze the real-time simulation. For input signal can be applied with convolution block, which can produce as output, audio signal filtering, connection to DSP hardware. This is the prototypes for real-time simulation. Next one, mind map, reflection and innovation. Compute y of n is equal to x of n into h of n for the given sequence and identify the types of the system. Analyze the length of the output sequence and applications in AI, that is nothing but convolution neural networks, real-time signal processing in IoT devices, digital audio enhancement and IoT processing, and then finding the output length of the output sequence in convolution sum. Next one, we can see the assessment. Define convolution sum. Convolution sum can be defined as y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Total number of samples in y of n will be m plus n minus 1. List the methods involved to compute convolution sum. Definition method, graphical method, multiplication method and tabulation method. Y of n is equal to x of n into h of n. H of n into x of n is defined as commutative property. Mention the steps involved to compute linear convolution. First, folding, shifting, multiplication, summation. List the properties of convolution sum. It can be classified into three properties: commutative, associative and distributive. Thank you.